All right, looks like we're right at 11 o'clock. Everyone, I see people still filtering in. But again, thank you everyone for coming to today's presentation. I'd like to introduce Justin Hendrickson. He's our product manager. Say hi, Justin.
Hi, everyone.
My name is Roman Walsh, and we'll be taking you through the ANSYS Spaceclaim 2016.1 update. Now, just a tiny bit of housekeeping before we begin is for those of you unfamiliar with GoToWebinar, how that works, there'll be a panel on the right side of your screen. Feel free to ask as many questions as you want. I'll be monitoring the questions during the presentation, and we'll have a little bit of time at the end for Q&A. So if I don't get to the question during the webinar, if we don't get it at the end, we'll definitely follow up with you afterwards. And also, if you do happen to step away for a little bit, we will be sending a link to everyone who signed up for the webinar too. So if you blinked or missed something, don't worry, we'll send you a recording afterwards. And with that, I want to turn it over to Justin to let him show you the latest and greatest in the Spaceclaim product.
Thank you, Roman. So it's my pleasure today to tell you about the new release and update to Spaceclaim 2016 that went out yesterday. We'll cover a few things in today's webinar. The first is to explain a little bit of the changes that we've made to how we release Spaceclaim and get you access to the newest capabilities. Second, we'll talk about some cool things we've done with providing broader immediate access to Spaceclaim. And then we'll go into details about what's in this update and show you a little bit of it live in the software. So the first thing is we've added something that we call Spaceclaim Try It Now. This is a really cool thing. Many times I've seen very happy customers of Spaceclaim who say, I'm using Spaceclaim on my desk at work, and a lot of my colleagues will walk by and say, wow, what is that? How can I try that? And being desktop software what it is, you usually would have to tell them, well, you're going to have to get an installer, we're going to have to get you a license. What's cool is with Spaceclaim Try It Now, all you have to do is share with them a link, in fact, right to the Spaceclaim website. You can click a button, and in, I want to say, 30 to 60 seconds, you can try Spaceclaim directly in your browsers. This is a great way just to let others experience and figure out whether Spaceclaim modeling would make a big difference in the way that they do their jobs today. One other thing to note here is there's some nice getting started utilities here, so it's also a good learning tool if you want to educate on Spaceclaim, but your sessions are limited to 2 hours, and currently it's only available in the US, unfortunately, but very soon, later this month, we'll provide access to Europe and Asia. Now let's talk about this release that went out yesterday. You may have noticed that it's called Spaceclaim 2016.1. So in the past, we've done what we call major releases and done service packs with each of those. We're changing that up a little bit this year, and I'll explain why. And we're going to do what we call point releases. These are not that different from service packs, except that they add in some additional new capabilities. Traditionally, our service packs mainly only included bug fixing and stability improvements, as well as maybe access to new translators. With these point releases, and part of the reason that we're calling them point releases, we wanted to get access to new capabilities faster to you, our customers. As a result, you'll see from the rest of this presentation some of the new things that we've been able to put in these releases. Our plan is every year to release 3 full releases of Spaceclaim. One that currently we'll name with the year, so Spaceclaim 2016 came out, for example, in December. This is 2016.1, and we plan to release 2016.2 toward the end of the summer. So this gives you 3 chances every year to get access to the latest and greatest formats, capabilities, and improvements. One of the trade-offs with this change in order to bring you new capabilities is that we're not always going to be able to guarantee that files saved and made in a later point release of Spaceclaim can be opened in an earlier version. This is pretty standard for software across the industry, and if it's something that you, in the way you use Spaceclaim, causes an issue, I'd love to hear about it. Tell me about it. Lastly, we also put a section of frequently asked questions on the SpaceClaim website. If you've never seen this before, I recommend you go there. It's a great place to learn more about SpaceClaim as a whole, as well as these individual point releases. Now let's talk about some of the highlights of this release. Here are the main category of things that went into SpaceClaim. In general, SpaceClaim is used in about 4 or 5 main areas. This is where we focus our work today. The first is using SpaceClaim as a design tool, creating new concepts that include parts, assemblies. This is where a lot of our drawing tools come in very handy. Some of the other areas are manufacturing prep for analysis, and then also reverse engineering and 3D printing. So when we do development for release, these are the 5 big areas that we focus on doing work in. In 2016.1, we've taken customer requested enhancements in each of these areas, and again I'll go through a couple of those here and put those in the software. Second of all, we've made a few changes to the UI, and third and most significantly, this is probably the biggest focus of the 2016.1 release, is we're releasing something called scripting for SpaceClaim, and I'll tell you in a moment a lot more about what that lets you do and how it makes SpaceClaim more powerful. Finally, we did a couple of things as well in each of the areas, including 3D print prep, and I'll touch on those. Now, some of the custom requested modeling improvements, more in the concept design area, are the following items that are shown here. And if you use SpaceClaim a lot, you probably had these same requests and needs, and I'll go over them quickly. The first is, you've always been able to create a lot of different types of patterns in SpaceClaim. You can create patterns of holes, protrusions, you can even create patterns of parts or curves. In general, if you were using driving dimensions in SpaceClaim, you could store as a driving dimension only the count characteristic of that pattern. People have often asked to be able to store things like the spacing dimension or the overall dimension. You can now store these additional inputs to a pattern as driving dimensions inside SpaceClaim. This, of course, means that you can access and edit a model using those dimensions and even drive it externally from other applications. Some other things, and again, being a short webinar, I need to keep moving, is we've improved the way that you can work with saving and managing the data in assemblies with external references. So one of the top requests that I've gotten many times is when you have an assembly that has a number of external parts in it, what does it mean when you ask SpaceClaim to save your changes to the assembly? Or more specifically, what does it mean when you ask to do a save as? What's really the meaning of that command? Usually, it's to make a new copy of your data. But when you have external references, do you want each of those to become a new version? Do you want them to overwrite the existing version? Or do you want to save them entirely as new document? So we now ask this option at the point at which you do save as. This provides a faster speed up. You normally would have had to do this manually. You can now automate versioning all of the modified files. Some other small things like splitting geometry is now more powerful and easier. You can pick any edge that defines a plane to split by. You can take these locking dimensions, which we added at SpaceClaim 2016, and you can click the button right on the mini toolbar to lock these. So access to locking is now more powerful. We also did a lot of good bug fixing with this new feature. You can do things like unlocking on the fly. A lot of the locks maintain their state a lot better than they did at the initial release. Finally, another thing that I have seen from customers so many times is when measuring angles on geometry. Okay, if you have a part or you're measuring these two edges, in this case these edges were selected, you might be able to measure the larger angle between them, which in this case would be 92 degrees, but we've made SpaceClaim measurement tools a bit smarter, so that they're always going to report an angle that is smaller than 90 degrees. Which generally as a user is the one that you intuitively expect to see. And we've done this in other areas in the measure tool as well, where we're making the reported measurements a bit more intuitive and more appropriate. Continuing on with the litany of ways in which we've taken customer input to improve the software, in our dimensioning, there's a lot of common requests that we all included in this release. The first is improving the way that we do the automatic dimensions you can quickly throw on standard holes. In this case, if you do the depth dimension, it now will only go to the shoulder if you have a point at the end of the standard hole. This is a nice small improvement. It's really a more appropriate way to dimension these. You can also do dimensions to the center of holes that appear on a face. Before, and based on true ASME standard, you're supposed to define a reference frame here first. We found that customers just didn't like the need to take that extra step, and so now we allow you to create a dimension directly to the center. Likewise, you can even do things like angles to the center of a hole. So you don't need direct geometry to create a measurement or a dimension to. You can dimension it to an implied reference from that geometry. Likewise, we also now have automated callouts on standard holes if they're through holes that look like this. And finally, another request that we've received many times is the ability to take notes on a drawing sheet and to associate them with the drawing view that they're nearby. And by doing this, if you drag your views around on your sheet, all of these notes, leaders, and other elements will now follow along with it. Now, a quick thing to point out, we mentioned that we introduced at SpaceClaim 2016 the ability to do live linking, which means if you're using keyshot rendering with SpaceClaim, you can make changes to geometry and update your existing scene in Keyshot, which is really great. What's new at this release is Keyshot 6, which came out at just about the same time as SpaceClaim 2016, is now supported with live linking. So this is a nice thing to note. Let's talk about user interface just for a second. You'll notice that at SpaceClaim 2016 we've been doing, first of all, some restyling. We have this new flatter, more modern look to the software, which I really like. But second of all, we've come and changed some of these embedded set of tools that appear at the bottom of SpaceClaim. For one, I used to see an entire large list of the selection types. We've now made this more dynamic, and we're doing this type of thing across SpaceClaim, where a lot of our UI controls are now updating and more dynamic. In other words, they'll change what they display to you on the fly. In general, this makes for an interface that is more efficient. The distance you have to go to get to interact with content becomes shorter, and the result is that you're able to work faster. Likewise, you'll see things like our error messages are now more interactive. Where you mouse over them, immediately you'll see things highlight directly in the view. These are also nice improvements. Lastly, we added something, and this also is often a customer request. You can turn on what we call here the zoom legend. And what it does is it will show directly on screen a relative size of your model based on your current view scale. So it allows you to quickly estimate the size of geometry using a visual display. Now, I mentioned at the beginning that the biggest bulk of work that went into this 2016.1 release is something called scripting. I'll tell you a lot about this now. SpaceClaim in general is a tool that we've designed and a lot of people tell us they love to use because of how fast and easy it makes it to create and edit geometry. People love the flexibility. However, sometimes people want to do things that are very similar or very automated. And in this case, they'll often come to me and ask, Justin, how can I automate the creation of geometry that's very similar? In SpaceClaim, we can create patterns, we can create patterns along objects, and generally you can still work very quickly. But if you're trying to do repeated operations, SpaceClaim could be faster. And this is one of the main reasons that we added scripting. Scripting allows you to record actions taken inside of SpaceClaim and to replay them. And here's what's neat. By replaying them, you can use this as a very powerful automation tool. So if I create one step, I could record it, run my script again, and create a set of steps in seconds. But second of all, I can actually use the actions that I record in SpaceClaim on different models. And I'll show you some examples of this. But again, the whole point of scripting, I would say the most valuable feature, is it can be used to automate your use of the software. You can run a script without needing to make the mouse clicks, without needing to make the selections. Now, to cover some of the details of scripting, it's a text-based interface to SpaceClaim. based in this case on Python. So if you're at all familiar with that, it's a very lightweight, easy to use. Include visualization and an editor of the scripts for SpaceClaim directly inside the interface, and you'll see that shortly. And of course, you'll have access to all kinds of operations, things like math operators, the ability to do loops, and to rerun functions. Here is a picture of that embedded editor inside of SpaceClaim. And you'll see you can define simple functions. Like here I want to create a block, and the input I'm going to provide is a side length. We also, in this editor, do really, really cool stuff that makes it easier for you to author and edit scripts. The first is you'll see as you type, we show you automatically the arguments and the possible commands that you can run. So you're not just looking at a blank, empty text screen. You're actually having an immersive one that helps you figure out what commands are available and what you can do with them. As I mentioned before, I think record is an absolutely critical feature. It makes it possible to author scripts without having programming background, without being a programmer. You can just use the interface and have it generate the script for you. Also, at this release, we've included documentation so you can see everything that's currently scriptable in SpaceClaim, and we've done some really cool things with what we're calling scripting groups, and I'll talk about that next. First, again, a reminder, what I was showing, here's two more examples, where again you can see the types of things that are available. And furthermore, when a script is running, and I've never seen anything like this in any other modeler or any other scripting environment, you can take your cursor and mouse over a line in your script. And when you do that, it will highlight anything from that line that appears as geometry on the model. This is so incredibly useful when you're authoring and debugging a script that you're writing. It allows you to actually see what's going on while it's happening. Now, the last feature of scripting here is what we call scripting groups. And the purpose of scripting groups is the following. If you author a script that generates something like this bolt that's shown here. So here we have a very simple script that automates the entire creation of this. You just put in a few characteristic values. I can run this script in SpaceClaim and I can generate all the bolt geometries that I want. But we wanted to go farther. We wanted users to be able to have a parametric geometry that lives inside of their SpaceClaim document. And what SpaceClaim groups are, you can take a script that you've authored and you can save it right to the groups panel. That's why we call it a script group. And this script now will live inside of the document. Furthermore, any parameters that you create can be used by that script, which means, and again, I'll show you this live and it'll be a lot clearer, I now can take this bolt geometry and simply type values into the interface. The script will automatically be run, and just as easy as it is for you to type, you will see the geometry change based on those parameters. This, to me, really enhances and expands the capabilities of SpaceClaim and the things that you can do with it. Now, a couple final things to point out in this 2016.1 release. We talk a lot, and we have people who are really thrilled about using SpaceClaim for prepping models for printing. A lot of our capabilities here live in our STL Prep for 3D printing add-on module. It allows you to edit, create, and clean up any faceted data sources. We're working on a lot of other neat additions for doing things like putting in lattice structures. At this release, we've added a new three-dimensional lattice infill so that when you shell a part, you'll see you can create these lattice infill that actually is three-dimensional. It's sort of lattice elements that go in both directions, horizontally and vertically, but they're also filleted in between the elements, which adds a lot of strength to the connections, meaning that you can have a very strong structure that is still very lightweight because there's a lot of empty space inside here. Some other really cool things is in SpaceClaim we do a great job of managing geometry surface-based models as well as triangle-based surface or facet models, as we call them. And we're connecting these two in new ways. The first example here is if I take any CAD model, and this is just a simple example model, obviously, and I convert it to an STL or triangle-based representation, we will remember on top of this data, on top of this model, which triangles belong to which face, so that as soon as you click any of these regions, we will select all the triangles as if there was a face there, even though the only data you're actually working with here is facets. Another area that we talk about users using SpaceClaim is model prep for CAE, and I just wanted to show a couple of the improvements we've made. The first is we added a new display option here called body vertices, and this allows you to display and render these point sprites at all vertices on solid or surface bodies. This can be very useful, again, for finding split edges or just visualizing exactly the characteristics of your geometry. Second of all, we've improved the way that enclosures and volume extract work so that they update in even more cases. We've added new power select options, the ability to select surface bodies by area. And then finally, if you were to put points on a face, we allow you to imprint those as points that will now follow any changes to the face. So if this face position is updated, possibly by your script, these points will automatically come along if they're pinned points. Lastly, we added some new capabilities for working with beams. They now will transfer to Workbench better, but additionally we added a new tool called split beams. And what this does is if you have a beam structure like the one shown here, and you have a number of these segments that come together, it's not an ideal representation to have this overlapping geometry. If you were to simulate this, you're doing a reasonable job of getting characteristics of the structure, but you could do better by automatically splitting these overlapping regions and defining these here as direct connections rather than independent beams. Now, as I've said at pretty much every release of SpaceClaim ever, we're always trying to make it possible to bring more data into and out of SpaceClaim and to bring it in a higher quality method. Some cool things that we've done at this release is obviously we've updated to some of the latest formats. Second, we've allowed you now for SOLIDWORKS NX and Creo to bring in PMI, part manufacturing information, dimensions, and tolerancing. So if you work a lot with any of these 3D CAD formats, you can now bring models that have dimensions on them directly into SpaceClaim. You can use them then to drive changes or to add additional dimensions for a drawing or any other export, maybe to 3D PDF or other types of formats. Second of all, we've enhanced our PLY export. Before we did import, now we do export, and we've added color to that as well. So some people like to use this, again, as a 3D printing format. Lastly, we've also added a format that probably not many of you are familiar with, but it's OpenVDB. This is actually a format that is a volume-based format, and I won't really go into any more details than that, but if this is something you're aware of, it might be of interest to you. Now lastly, we've done something else to get even more value out of what we import. If you're importing assemblies from a number of systems, in this case let's say a SOLIDWORKS assembly, a lot of these major CAD systems store data in assemblies in configurations, which means I might have one configuration of the assembly which has a various list of parts and position of those parts. I might have another configuration which is different. It might have some additional parts or maybe some removed parts, and the parts might be in different locations. Previously in SpaceClaim, you could only bring in the last saved configuration of that assembly. Now, at SpaceClaim 2016.1, you can select, using this assembly browser, which configuration you want to bring in. So again, we're always trying to make sure that you get the most and highest quality data out of all of your geometry import and export to SpaceClaim. We're also working, as you may have noticed in our previous releases, to add and improve the way that you can create dimensions and tolerances. I won't go into much detail. The main thing to note here is we've added semantic datum targets. So now you can create these datum targets. They update with changes to their geometry. They appear in the structure tree, a lot of great stuff. Another really common customer request we've gotten a lot, and this is really cool, is that if you have or bring in, let's say, that SOLIDWORKS assembly with PMI, remember we now read in PMI from more locations, and that PMI is on the assembly, or even it's on parts within the assembly, Those dimensions technically live inside of each part in the assembly, but we have a new command called show all annotations that will let you immediately view all dimensions that might appear on any parts at the assembly level. Sometimes this is a really great thing to do to immediately view which things have been annotated and what are the characteristics of those annotations. Lastly, I'm just about done, a lot of stuff to cover here that's new in the release. We've done a couple small improvements to sheet metal. We've added a new dimple-based form, which is shown here. Second, we've added some new inputs to creating tabs in SpaceClaim. So if you create one of these automatic tab junctions and corners, you can now specify two types of clearances, the clearance from the back wall, basically the offset distance of the tab, as well as a clearance from either side of the tab. So there leaves some space so that when these parts are manufactured, you can make sure that they'll fit together. So to summarize, nice changes to release cycle that generally get you faster access to new functionality. One of our focuses here, the two big things, were scripting and a lot of just customer requested improvements. And then lastly, this cool new feature that gives you immediate access to SpaceClaim wherever you are.
Lots of really cool stuff, Justin. While you get SpaceClaim set up, some questions came up on scripting. What made you choose Python over other languages? And can you use other languages?
Good question. At the end of the day, what a script, and we'll talk about scripting right now, is I can go to this file menu, new, and say script. And this brings up our script editor. And as you said, scripting is a text-based interface to SpaceClaim. What we're using here is Python, and we tell you that right here. And part of the reason that we use Python is because it has the least number of constraints and sort of programming concepts that you have to understand. Python is often thought of as the most accessible, most easy-to-use language. That's why we chose it. Okay, you can say something like my variable I equals 1. That's it. That's all you have to write. No special semicolons, no other formatting. You can't use other languages here. Technically, you can use C# because what we're using here is basically a combination of Python, so it supports the full Python language, but it allows you to make C# type calls, so it's actually like an extended version of Python. But in general, those are your only options. Do you have other questions, Roman?
One question came in, I think you'll show some examples, but are there some examples that people can use to help them get started with this?
Yes, great question. So I'll cover some of these things, so why don't I dive into it? Roman, again, feel free to interrupt me. To answer the example question first, this is our scripting editor. You can type and author scripts all you want. Things appear down here based on what you do. Again, just to show you how easy Python is, you can say I equals I plus 1. Okay, and if I run this script, and this print function will just print a display out to the bottom. So if I run my script here, let me move some. You'll notice it's going to run my script. You'll see it execute the lines, and it prints this value, in this case, which is 2, because that's I plus 1. Not a lot of syntax, not that hard. Now, in terms of examples, we really want to help you author scripts and make it as easy as possible. One of the ways in which we're doing that is we have this button right here which says Insert Snippet. This is one of our ideas for making scripting easier and more accessible. You can click this button and you suddenly have access to a host of embedded examples of scripting code. You'll notice these are grouped here by different topics, okay? But for example, if you wanted to see the fill tool and how to fill an object, you could go in here. In this case, there's only one thing inside of this folder, and you click this fill. And immediately, it dropped, in this case, just one line of sample code. So here you would just call the fill command, you'd execute it, and you'd give it a selection. In this case, it's getting the active selection. So if you want to see this in action, it's very simple. I could pick some piece of geometry. Let's say I pick this face, okay? And I hit this play button up here. It's called Run Script. And it's going to execute my script. And guess what? It ran a fill on that face, and it removed that face. Okay? We just did our first bit of scripting, not too difficult. In terms of more sophisticated examples, there's a bunch in here. I don't know what to think of best, but here might be an example of the move tool. In this case, you could move along a trajectory, move up to an object, let's say up to. You'll notice here it dropped in 5 lines of scripts. This to me is so helpful. You don't always have to figure out how to do something. This was our first idea. The second thing, which I think is Better than that, in terms of making scripting easier to use, is having access to, let's take a look at just one of these parts, record script directly from things that you do inside of SpaceClaim. So the way that you do this is you take this record button and you turn it on. You'll notice it's now highlighted. So now anything I do in the interface that is scriptable will be recorded here in my script file. So to start with a very simple example, let's say I take this face at the end of the handle and I pull it. So I'm going to use SpaceClaim's pull tool. I'm going to make a modification. As soon as I let go, you'll notice that 4 lines of script appear. We can go over them. I think we're going to do a webinar in the future that is training purely on scripting, so stay tuned for that. But today I just want to give you a flavor of some of what's possible. But you'll notice here it basically recorded a selection, which face that I selected. It then set some options. In this case, it's not really doing anything. It set an extrude type, and then it just called extrude faces and gave it a distance. Okay? So here what we're going to do is just rerun this script. You'll notice I can run it once. I can run it again. What I did manually has now been automated. And of course, at any time we can go back in here in the undo and we can roll back those changes, which is pretty cool. Let's look at some other examples. And again, I'm going to use record because I think it's the most powerful way to work with scripting. But let's say that I wanted to remove the fillets that appear here. First, let me show you another one of these examples. So I'll click this snippets example, and I'm going to go here to power selection. Okay, this is the same selection panel that we have over here. And I can pick bodies, edges, faces. In this case, I'm going to pick faces. And you'll see it gives me an option for face area by value. In this case, rounds by radius. Okay, smaller or equal to. And again, this is based on the active selection. So if we want to see this work, it's as simple as picking maybe a fillet like this and running my script. You'll notice it did do the power selection, but there's one additional line that I have to add here, which is this selection gets stored here in this object, and all I have to do is to tell SpaceClaim to set this as the active selection. So after I add this line, if I run my script now, you'll see that it's going to do that power selection. It's going to select all fillets smaller or equal to the one that I selected. Let's do it again, but select a bigger face. So if I click this one, run my script again, you see how it's automating. Before I would have had to go over here, click the object that appeared, and select it. This is the power and the point of scripting. But let's do more. So we selected these fillets, which is just fine. Again, I can illustrate that as follows. But let's fill them in. So a second ago, I showed how to do a fill function. So here, let's, again, using record, I'm just going to hit the fill tool. You'll notice, again, it generates a line of script. Selection of what I filled, and then this simple fill.execute. We'll tie these two together by taking this selection object and passing it in here. You'll notice the thing I mentioned earlier. When I mouse over these things, it highlights them in the view. This is so cool. At least I think it's so cool. I'll undo my change, so here are my fillets, and now I have a script that does 2 things. I can pick a fillet, I can have it automatically select them, and then it's going to execute fill automatically on all of those fillets. This is a request I've gotten many times. Justin, I'd like to automate removal of fillets from geometry. And I now say, great, here is a 3-line script that will do exactly that. And this is all pretty cool. Again, I can do this as many times as I want. So that gives you a first flavor. Let's do something else. So this was a simple recording. Let's make some changes to my part. And 2 of my favorite tools to make changes are the pull and the move tool. Let's go to the pull tool, and let's do something like extruding this face out. And maybe we'll extrude it out by 20 millimeters. And now to make this handle stay the same width but just get longer, I'm going to use a different tool. I'm going to use the move tool. In this case, I'm going to go negative 20 millimeters too. So here I did 2 types of geometry edits. In this case, hold on, instead of typing that, let's just drag this in and type in a value. You'll notice both of these things that I did got recorded to my scripting panel, which is pretty cool. Okay, and so we'll see what happens if I replay them. Again, here undo is my friend, so we'll do an undo of both of these operations. Here's my original handle, and we'll just rerun my script. We'll see if it redoes my changes. And it looks like it did. To make it obvious, I'll keep running it. So that's pretty cool. Again, you can show how you can automate editing and using of tools. So let's roll those back. Well, let's actually go forward a couple. Maybe something like this. Okay. So let's do even more. Let's do something more complex. In this case, I'm going to pull this back in just because I don't like how it looks. And of course, we'll get some record for that. But we're almost done with recording. So what we're going to do is, after making these changes, let's make a copy of this entire handle. So in this case, I'll use SpaceClaim's Move tool, and I'll copy it up. And again, just as you'd expect, this gets recorded. Okay, so I'm going to undo this change. So hopefully you guys can bear with me, but now I'm going to make use of what I just did. Again, I can replay the script to show you it works. It makes the changes, and it makes a copy. All right, pretty cool. I like that. But what I want to do is to make changes in different amounts and to make copies of each of them. That's what I'm trying to show you. This is where the power of scripting becomes more valuable. So I'm going to create what's called a very simple for loop. So I would say for I in range 1 to 6. So we'll say we're just going to take this variable I and we're going to give it values of 1 to 6. That's all that does. And then I'm just going to indent this because this is going to run 6 times. That's what it's going to do. Now, in order to have it actually affect the output, it would do the same thing right now. I'm just going to take these values that appear right here. I'm going to multiply them by my value. So it's going to go 20, then 40, etc. This one's negative 20. I'm going to multiply this also by my value I. And this likewise, this one it moves up. I will multiply it by I. Now, I'm just going to do one other thing here, which is I'm going to, after each change, I'm going to basically do the opposite of the changes that I just made. So I'm going to do this same change here, and instead of negative 20, I'm going to go positive 20, and then we'll take the pull operation that I did. We'll drop this down here as well. And again, instead of positive 20, we'll go negative. In a second, you'll see what this will do. So we'll run this now, and we'll see if I mess something up. Ta-da! So what we did here, and this is really the power of scripting, I made a family of parts. So I took any changes that I wanted to make, and you can imagine these could be your changes. They could be rotating geometry, whatever it is. And with just a few additional lines, I was able to create an entire family of geometry. The uses of scripting is really endless. It can be used as an incredibly powerful tool. And I'll show you just very, very quickly 2 other examples, but I think this gives you a great idea. The first is, and here are some other script examples, is the picture that I showed in the slides. Here's a script that quickly creates a really cool staircase of stairs. Again, for me, the most valuable use of scripting is automation and creation of geometry. So check out how cool this is. So here's an entire set of stairs that we created with a click of a button. I put some parameters at the top of this. You'll notice here I like to define variables. We could change here the radius. So if you want this staircase to be half the radius, we want to reduce maybe the height between the steps, you want to be closer together, whatever it is, I can then just rerun this script with the new values. I get an entirely new staircase. Okay? This is why scripting is cool. Let me show you 2 other quick examples. The next one is what I talked about, scripting groups. So here's an example of an auger. So somebody wanted to create a very complex surface profile. You'll notice here the spacing at the beginning is not as wide. It gets much tighter at the bottom of this blade. Okay? The script that generated this has been here stored as a script group, which I mentioned before. So all I did was open this SpaceClaim document, and here you'll see this script, here labeled auger, and you'll see the variables that go into it. If I change any of these variables, like for example I change the length variable, let's make it half as long, the script is going to automatically rerun, and almost magically the geometry is going to change in front of us. Or at least hopefully it will. Aha! So now we have a blade that's half the length. It still is doing this variation between the tighter pitch at the start and the looser pitch at the end. If you wanted to change this even more, I could change maybe the start pitch to instead be something like 20. This is such a great extension to SpaceClaim. You can imagine creating all types of very complex parametric geometry. just like this. Here I edited the start pitch. You'll notice now it's much closer and tighter together. So one last final example to hopefully get you inspired to try out SpaceClaim scripting is the following. So here is a model of a cylinder and piston, in this case and crankshaft, inside of a model of an engine. Another way in which scripting can be used is to do things like animation, right? Scripting lets you extend the capabilities of SpaceClaim. So here I have a script that we created, it's not that long, called animation. I'm going to open this up. And when I run this script, okay, what it's going to do is it's just going to set the positions of these objects. So here I'm going to run it. This script, which excites me, is essentially bringing SpaceClaim to life. So you'll notice here it's updating and moving these. In this case, it's also keeping these geometries here, this crankshaft connected, okay, and moving it up and down inside here. One of the things that can be done is the speed, for example, is a variable that appears here. Basically the number of degrees per step that we want to undergo. So in this case, let's maybe slow it down, or we could speed it up. Let's try slowing it down first. We'll rerun our script. You'll notice here this moves slowly, in this case a bit more fluidly. It's taking more steps along the animation. Let's try speeding it up instead. In this case again, I'll set the geometry back. Let's do something like 6. We'll run that instead. Now it's going to move quite a bit faster. Also, if we come and look up here, you'll see that we included in this animation opening and closing of the valves. So as we move, you'll see that these open and close, again simulating the intake and outtake of the fluids inside of the cylinder. So to me, again, this is just so cool. You can see the motion of the geometry. Scripting gives you the access to automate SpaceClaim and to extend it to meet whatever your needs might be. Like I said, I think we'll do a follow-up webinar in the future to give you guys a more in-depth look at some of the ways in which this can be used. So without any further ado, I think we'll open it up to Q&A. My apologies for running 10 minutes over time.
No problem. A ton of good questions did come in. Let me, and now that I've gotten to the question part, I actually minimize them. But one of the questions came in was, is the text file just plain, is the script just plain text? Like, could you then edit it outside of SpaceClaim?
Yes, you could edit it outside of SpaceClaim and then just paste it into our script editor.
Great. Bunch of questions also came in. Can you create custom buttons with the scripts, or is that reserved for the API?
Now that is a really good question because it's something that we are planning to do. So we're thinking exactly the same thing. You could do it today with the API because in the SpaceClaim's API you can create buttons. That's one of the things it does. One of the other things you can do through the API is you can tell SpaceClaim to execute a script file. So if you wanted to, or we'd be happy to do it for you presently, is you can create a button and have it execute a script file of your choice. We don't directly sort of facilitate that, but I think we will in the future.
An interesting question came in about people that are using Workbench. Those parameters that you showed in the groups panel, are those accessible to then drive a model or drive an optimization?
Yes, completely accessible by Workbench.
And I think that's what's huge too, because that elevates the amount of optimizations, the types of optimizations you could possibly do. So it's not just pull lengths, move dimensions, translations. You can do a ton of stuff.
I entirely agree. This is a great example, right? Parameterizing this type of change, you couldn't do directly with any geometry tool.
All right. A bunch of questions came in, which I think is the obvious next step, about sharing scripts with people and growing a community that's there. I mean, I think it's a great idea, and it's something we're going to look to do and look into. But as of right now, this is a brand new thing. There's not a place to do that, but it's something that we'll investigate. I don't know if you want to comment on that, Justin.
I totally agree with what Roman is saying. Our first just priority for you is getting scripting to be as powerful and easy to use as possible. That's step one. Step two is just like you guys are thinking, how can we facilitate people who are creating scripts sharing them? It's something we're absolutely going to keep in mind.
Great. There are a couple tiny questions here and there, but I think I got to everyone that asked a question. I mean, the only other thing is are there example scripts? Can you just show where those are and how people can get them, like saved with SpaceClaim?
Yes, let me show a couple things. I think the first place I pointed to was, again, this snippets. This is where we have example code, right? Inside of all these folders directly in the interface, these are examples. I think we need to add more end-to-end sample scripts, like, for example, the ones I've shown here. We don't include those right now. I think in the next release, I'll make sure that we include more of them. So that's two answers for you. The third answer is, if you go to your SpaceClaim install directory, so if I go to something like Program Files, SpaceClaim, inside of here, there will be a scripting help file. In this case, I'll do something like this. And you'll notice down here there's a scripting class library. This is the documentation here for scripting, which is nice. And there's contents. If you want to see the list of all scripting commands, I can click this. And this is just also a good place to see what's possible. So here there's a copy command. You can run combine, merge, and split objects. And if you want to see how to do that, here are like the functions on that. So this is just another place to go to learn more. But in short, the other answer is we have to continue to add more samples and to make it even more supported.
Great. Justin, I think it was a great presentation. There are, as always, some questions that are piling in. We're already 15 minutes over at this point. So for everyone's questions that we didn't get a chance to get to, we'll follow up through email. And Justin, thank you so much for the presentation. I'm excited about all the new enhancements that we've added, and really the scripting stuff opens up a whole new world for what you can do and the models you can make in SpaceClaim.
Thanks, Roman. Always my pleasure.
All right, everyone, have a great day.